Senior 3 students, you are welcome to our lessons at BAC Science Education Consultants, where our slogan is learning must continue taking place so that we keep solving all the societal problems, because science is highly needed more than in any other period. Many things happen in real life. We look at them, but then sometimes we can't explain. That's why I'm coming in today, that we can have brief explanations about certain things that happen and why do they happen. I'll just give you a few examples. Some of you have ever been to the beach, others to rivers, others you have seen certain water bodies, especially when the water is clear and you can see the sand or something at the bottom of the river or a lake or something. I'm sure some of you have realized that when you look at like water in a pool, what the pool looks like it is shallower than actually what it is. When you look at water in a pool, if you look there with your eyes, if you are to measure the distance that your eyes assume is actually not the actual distance. Your eyes see the bottom of the pool being raised a bit. It is a certain effect. If I press anything, now look at this. You can see how it is. It is straight. I know you will do it after this lesson. Just get a glass, put water, then get anything that is straight. Can be a mingling stick, can be any piece of wood. You can use even a mathematical set, anything that is straight. You just press it here in the water in a glass. I know you are actually seeing some effect. And I know you have been seeing this effect. You can see it is a bit bent. But in actual sense, the thing is not bent. This metal is not bent. So what brings about that one? When you view from the side or from up, it looks bent. Also, if you put a jug or a cup in water, it still looks bent. Try it. It looks shorter than what it's supposed to be. If I put any dot, you can put a pencil dot. If I put this dot, and on top of that dot, I press there, this one, and I look from above. Now you also look from above. You realize that this pencil or this marker that was pressed here, when you press there and you try to view from above, it is not seeming to be at the point where it is. It's a bit raised. Why? If we are able to answer that why, we can convince ourselves, and then we add on a few things. Then we say the lesson is done and we shall be successful. Now, why all the four that I've talked about and several many other things? Why? Why? Let's look at, for example, what I ended with. You have your glass. Something at the bottom here. Maybe a dot. This glass, it has some liquid in it, transparent. You are viewing from above. So, light from here, when it strikes this surface, there is something that happens to it. It goes away. It goes away. And light from here, when it strikes this surface, it is also bent towards some other direction. So light has moved like that, and it goes like that. So at this point, if somebody is up here, if somebody is in this area, up here in that cloud, and looks at the rays, this one from here, at this point is bent, and this one is bent, and finally, the person may be convinced this dot is at this point. Which effect brings that? What causes it? It is because when light reaches at the boundary, now this one is called a boundary. Or this is, let's say, water. This is water, and maybe this is air. There is change in the direction of light. There is change in the speed of light. Therefore, this effect is given a specific name, like any other thing must be named. And this is what we call refraction of light. Therefore, what is a refraction of light? What is a refraction? Yes, what is a refraction? Somebody can say it has much to do with being light is traveling from one medium to another medium. So this one is taking us to what is refraction. Get a paper and write some things. So what is refraction? We are going to write what refraction is. Yes, refraction is the change in the direction of light as it moves from one medium to another. For example, light is moving from air to glass. It has changed direction. Air is one medium, glass is another medium. Light is moving from water to air. Those are two media. Media is the plural form for medium. Light is moving from water, maybe to ethanol. Those are two media. So, as long as light is moving from one medium to another, then and changes direction, that is what we call refraction of light. And we are saying, what causes it? We say it in the definition, that it is caused by change in the velocity of light. When the velocity changes, then the direction changes, and we can have an illustration. Illustration. This one you can call it a boundary. You can say this is AB, and we call it a boundary, so that if this is glass and then this is air, glass is denser than air, there is something else we shall talk about. Then we shall put an angle of 90, a normal. So if it is moving from glass to air, it is coming like this. This is the ray of light. This is the source. Maybe this is P. This is point Q. When it reaches here at the boundary, if there was no this, if this is still glass, if the whole of this is still glass, it is not moving from glass, it is continuing in glass, then it would have continued like this. It would have continued like that. It would have continued like that. But you are saying there is change in the direction. So it will no longer move along that line. It will either move this direction or the other direction. I will explain it later. But for this case, it will move in this direction. Maybe you can say this is a point R. Then we want to name all this. So we can say that AB is the boundary. Then we have PQ. This is the incident ray. Remember, you also studied it in refraction. It is the same. Incident ray. Then, since the incident ray, there is a certain angle here that we normally call I, and then this one that we always call I. So what is angle I? Angle I is the angle of incidence. Then we have this ray from here to here, through I, after refraction. That is the refracted ray through I. And then angle R is the angle of refraction. These ones are very, very, very important. Then I have said there is a reason. There is a reason why this one moves in that direction, not this direction. And it is very important. We shall be able to discover that if light is traveling from a dense medium to a less dense medium, for example from glass to air, then light will be refracted away from the normal. This is it. It would have continued like this one. So it has two options. Either go towards this normal or away from the normal. So this is denser than this, so it goes away from the normal. And if it is from a less dense to a dense, then it will move towards the normal. We need to take that note. 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 Yes, that if light travels from a dense medium to a less dense medium, it is refracted away from the normal. And if it travels from a less dense medium to a dense medium, it is refracted towards the normal. We can just have examples. We can have examples. For this is one of the examples. This is glass to air. It is refracted away from the normal. We can have water. There is water here, and then there is air. This medium, there is water. This is the boundary. From water to air, which one is less dense? Which one is dense? Water is denser than air. So where will the light go? Away or towards? Away. So light comes from here. That's the path of light. And then this is our angle of incidence. When it reaches here, it would have continued. It would have continued in this direction. But because there is change in the speed, then it will go at a certain angle like that. And then this is the angle of refraction. And you don't have to forget to put the arrow. That is, if we have water to air. If it is water to air. Let's have, maybe you have air to glass. This is glass. How does light behave at the boundary? That's the boundary, and that's our angle. This is less dense than this. Therefore, it will be refracted towards the normal. So, you can have our ray of light. Then, it would have continued like this in a straight line, but there is change, so it is refracted towards the normal. And this is the angle of refraction, whereas this is the angle of incidence. This is very important because we shall continue using the same things. We shall continue using the same things that light, if it is traveling from a dense medium to a less dense medium, it will be refracted away from the normal. Then, if it is from a less dense to a dense, it is refracted towards the normal. From dense to less dense, away. From less dense to dense, towards. I can put it in a song. From dance to less dance away. From less dance to dance towards the normal. I would not want to sing. I want you to do this as part of your exercise. This is your exercise. Sketch diagrams showing. Sketch, 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 sketch. Sketch a diagram. Sketch a diagram showing refraction of a ray. That's a ray of light that is passing from glass to water. You have to first know which one is denser than the other one, glass or water. Then please don't forget the song. I don't want to repeat it. Do this work. Send it to us. Our contacts are right there, and we are called Back Science Education Consultants. Our YouTube channel is Back Science Education Consultants. For you to always be notified of the new work that we put there, subscribe. Don't forget to tell your friends to subscribe. As they subscribe, tell them they can also tell their friends to subscribe and enjoy, so that at the end, even the enemies can enjoy and finally become your friends. That is for now. That is the one that we can say for now. May you have blessed time.